So before we move into continuing into new content, I want to talk a little bit about what's going to happen for the next couple of weeks. Today, we're going to review a few loose ends from previous lectures, and then we're going to do a in-class review of homework 7. And so I've moved just a tiny bit what's happening for the next couple of weeks. So I wanted to share with you what this looks like. So this is similar to what's in your schedule on the syllabus. I've just moved a little bit back what's happening in November 8th and November 15th. So I'm going to talk to you about that right now. So November 8th is what we're going to do next week. We're going to talk about causal inference and treatment effects and effect sizes next week. And I have some effect size papers that I'd like for you to read before class next time. I'm also going to give you a homework assignment today that instead of being due on Friday is going to be due on Monday, like today's homework was due. So you'll get all of that at the end of the day today. And then on November 15th, which is the week after, I'll start to introduce logistic regression. So that's pushed back a week from where we'd planned it. I have a paper for you to read before class, which isn't showing up here for some reason, but it will show up in the my words aren't working today. Module on Carmen. Yes, thank you, Adriana. And so there will also be a homework 9 that will be due on that day. Again, we'll do that on Monday. There's another thing that I will need you to do, which will be to bring an idea of your research question to be addressed in your rough draft to class on this day. So you'll notice that on November 22nd, your rough draft of your final homework assignment is due. So I want you to bring to class, and we'll workshop the ideas for your research question that you will address in your final assignment. Okay, those are the rest of November pretty much, I think. Isn't November 30th, so we'll have one more, November 28th. Okay, basic questions on how these things are proceeding or look like they're proceeding here in the upcoming weeks. Okay.
Excuse me, Dr. Logan.
Yes.
The idea of your research question, our research question, is based on the data set that we have, or okay, perfect.
Yes, so it should be for your final assignment, and I will get that uploaded to Carmen this evening so that you'll have an opportunity to read it to prepare yourself for what will happen in the final assignment. But the main idea of your final assignment, I believe I go over this a little bit in your syllabus, is to write about a page about an analysis that you will conduct with a data set of your own.
Thank you.
Mm-hmm. Okay. So I want to talk a little bit more about repeated measures designs. I introduced repeated measures designs yesterday or last week, but I'll tell you what, everyone, the problem is I forgot that when we teach online, 3 hours is too long. It's just too long. So today we're going to be teaching this class online. We will not go the whole 3 hours because that is just too dang long. We're going to go shorter than that to be online, and I'll give you extra readings. Okay, so for repeated measures ANOVA, I want to talk a little bit more about this because last time I really just sort of showed you how it works within the SPSS program. So today I'm going to talk a little bit wider conceptualization. So repeated measures ANOVA can be used anytime we have multiple measurement occasions, repeated measures. So one very common example is measuring how something changes over time. So for example, measuring statistics knowledge both before and after you've taken this course. But as Adriana pointed out last week, we can also use this for more than 2 time points if we have maybe measuring math skills in grade 1, 2, 3, and 4. Measuring how some sort of skill or ability is changing over time. But repeated measures doesn't necessarily just apply to how something you think would mature over time, how we think about it in developmental science. It can also be for any other within-person factors. So remember we talked about the difference between within-person factors versus between-person factors last time. And within-person factor is something you expect to change within a person, whereas a between-person factor are things that you expect to be different between people. So for a couple of examples here is you might measure how something changes under specific conditions. So I might measure everyone once, maybe on their memory performance when the room is very quiet. And then I can measure you again on your memory performance when you're in a very loud room. And I might expect that there would be a difference between those two measurements. This is within person if I'm measuring everyone once in a quiet room and everyone again in a loud room. But again, it doesn't have to be restricted to just 2 conditions. We can have multiple conditions. So you can measure memory performance for short, medium, and long strings of numbers. So you could say, repeat this back to me, 2, 7. Good job. How about this one? 7, 4, 2. That's a medium string. And we would expect potentially that memory might get worse the longer the string of numbers you have to remember. So this is just illustrating a couple of different ways we can measure things multiple times.
Dr. Logan, sorry to interrupt.
Please do.
Is this PowerPoint supposed to be uncommon? You're muted now.
Yes, it sure is. Hang on, let me see what's up. Okay, I think I have all the right buttons clicked now. Sorry about that, everybody. That you should be able to see it.
I see it now. Thank you.
Okay, sorry about that. It's a short little one because my main goal is reviewing homework 7 today. Oops. Okay, so here we are talking about a couple of different ways that we can think about repeated measures, because repeated measures isn't just how things grow and change naturally over time. It can also be how things change when we manipulate something in the environment. Now, this matters because of the null hypothesis of what the repeated measures ANOVA is asking. So the repeated measures ANOVA is always testing whether there's a difference between the means of the groups. So the null hypothesis is that there's no difference between the means of the groups or between the means of the measurement occasions. So the complexity of this sort of scales with the complexity of what it is that you're including in your repeated measures ANOVA. So when I have two measurements or two repeated measures, the significance test is pretty clear. If I have a significant effect, it means that one group is different from the other group. And that's the example I showed you last time. Group 1 is different than group 2. But if I have 3 or more assessments or measurements, occasions, then it becomes more complex. If I have a significant finding, remember the null hypothesis here is that the means of all of the groups are the same. And so if I have a significant effect of my of time or of whatever it is that I'm repeating, then it indicates that all of the groups are not the same. Which sometimes that's useful, but oftentimes that's not quite as useful as what we want. So to get a more specific piece of information about what we really want to know, then we would have to use post hoc contrasts. And so I'll play this out a little bit for you before we move on. So here's an extremely fuzzy graph of a hypothetical measure. I have the mean here on the y-axis, and then I have 3 time points across the x-axis. And you can see that here's an example of some sort of construct, and it's going up over time. At time 1, it's the lowest. At time 2, it's a little bit higher. And at time 3, it's even higher than that. But if I get a significant effect of time within my model, that only tells me that the means of all 3 of these are not the same. It doesn't tell me which is specifically different than which else. Is time 1 different than time 2? Or is time 1 different than time 3? We don't actually know yet. We just know that somewhere in here, somebody's mean is not the same as somebody else's. So this is where the pairwise comparison that the repeated measures ANOVA will give you becomes very useful. So here's an example output like the one I showed you last time, where we have all of the mean differences between each of our groups. And this time we have 3 groups. We have time 1, time 2, and time 3. And you see that we'll first get a contrast between time 1 and time 2, and then a contrast between time 1 and time 3. And this tells us that each one of these is significantly different than the other with our significance tests. And as you all learned about in GLM1, when we have multiple comparisons that you make within one particular analysis, so right here, the mean of 1 versus 2 and the mean of 1 versus 3, we're now looking at the mean at time 1 twice. So we need to account for that using some sort of correction. And these repeated measures ANOVAs will automatically include a penalty or adjustment for different kinds of corrections for this multiple comparisons. So here, it's automatically already using this Bonferroni correction, which just divides your critical value by the number of contrasts that you're making. So here, instead of making just 1 contrast, we are making 2. So we're dividing it in half.
What if we had nested samples? Oh, sorry. What if you had nested samples? For example, if you wanted to compare 2 classrooms and before and after intervention, and then if you wanted to compare individual students within each of those classrooms, how would you go about doing that?
That's a great question. So with nested samples, where you have multiple students per classroom, usually the way that we like to account for that is in a hierarchical nesting structure. So it's a slightly different analysis, but still based in the general linear model. But if you only have 2 classrooms, it's slightly different. With only 2 classrooms, typically we would either ignore the fact that those kids are nested because there's not much we can do about it since there's only 2 particular classrooms. Or if the random assignment that you have is per student, then we can include which classroom the kids are in as a predictor. It's called a fixed effect. That was a lot more information than I think you meant, but can I ask for more information about your scenario in terms of whether, like how your assignment of conditions was done?
No, that was very helpful. I was just wondering if we were supposed to apply it twice over, or if there were adjustments that we were supposed to use to account for any additional errors from that.
So no, if you only have, well, it depends. So here we're talking about differences, contrasts that you're making between time point observations. So if you have data that are like this, where you have 3 times, but they're measured within separate classrooms, for example, depending on the research question that you're asking, you can account for the fact that you have multiple kids in one particular classroom by using which classroom someone's in as a predictor. But it wouldn't involve any additional post hoc contrasts.
Got it. Thank you.
Yeah. So if I've done a repeated measures ANOVA and I want to write about it in text, here is how I would recommend that you do that. First, write about the means of your groups or of your repeated measures. Second, write about the overall F-test. So that's the significance of the null hypothesis that the means of the measurement occasions are all equal. And then finally, you can report the results of that corrected differences test that I just showed you between each pair of observations. So assuming that that's of interest to your research question, is time 1 different than time 2 and time 2 different than time 3, that would be the next part that I would suggest you write about. And so here's an example of a write-up that you might see, something like this. The mean of math achievement at the 3 time points was 11, 19, and 23. That's the means of my groups. My means of my measurement occasions. Time was significantly related to the mean math score. Here's an imaginary F-test. And then here's the corrected differences between pairs of observations. The Bonferroni corrected post hoc tests suggested that time 1 was significantly different from time 2 and 3, but that time 3 was not significantly different from time 2. So here's an example of how you could write that up within a paper. Now, I didn't show you what this output would look like, so it's a little bit ephemeral, but just an idea of what it could look like. Actually, more things before I move on to a slightly more complicated piece of repeated measures ANOVAs. So the other fun thing about repeated measures ANOVAs is that they're still ANOVAs. So you can have all kinds of other stuff going on within them. So here you could have more than one repeated factor. So for example, we measured enrollment in school districts in 2018-2019 and again in 2019-2020, where our repeated measure was time. And then we also measured social media use. We measured Twitter and we measured Facebook. Now these 2 different things they're separate, but they're both repeated measures of different constructs. Now you can also have factorial conditions where you may have seen things like this, 2x2 ANOVAs. So a 2x2, the idea there is that you've measured something more than once across levels of another construct that you've measured more than once. And so, for example, here I have measuring memory performance on both short and long strings of numbers, both in a loud room and a quiet room. That's 2x2 for 4 total conditions. So following that example, if you have a 3x2, it just means you have one of your factors with 3 conditions and one with 2 conditions. So like measuring long, medium, and short strings of numbers and quiet and loud rooms. So that's a total of 6 repeated measures that I would have had of this group of people. And so for us, what we had here was not a factorial ANOVA, because we had time measured on enrollment and we had social media measured in Twitter and Facebook. But if we had measured Twitter and Facebook each 3 times a few months apart, for example, measured Twitter followers in January, then Twitter followers in March, and then Twitter followers in July, and the same thing for Facebook followers in January, March, and July, that would be a 3x2 factorial ANOVA, where I have 3 times of observation and 2 different social medias. And what's really cool about these types of setups and these types of experiments, if you set them up this way, is that you're able to measure and isolate the effects of each one of these conditions on your potential outcome. So if I'm looking for number of followers on social media, for example, here in this, for my school districts, then I would expect that it would probably increase over time across these 3 time points. And I have no hypothesis about which one would be higher than which other one. But you can ask a bunch of different questions about how social media use changes over time using just these factors. One more thing about these is that because each one of these conditions was measured, this outcome was measured in all of these different instances, 6 different conditions, you not only can look at the main effects of each one of these, but you can also look at the interaction between these. And so, for example, in our Facebook and Twitter example, we could look at how growth in social media changes over time, and we can look at growth in followers and whether that depends on which social media we're examining. So a research question using this would be something like, does the amount of growth in followers on social media depend on which social media we're looking at? And then the last thing I want to mention about repeated measures ANOVAs is that it's, in addition to these things that you've measured repeatedly, you can also include covariates, just like every other analysis that we've done in the GLM series. You can include covariates that aren't necessarily factorialized or measured multiple times. So things you may want to control for that haven't been measured multiple times, like income. These are different pieces that could be potentially important to your outcomes, but that you haven't necessarily measured multiple times because you wouldn't expect them to change over time. And these can also be interacted with your key factors if you want them to. That's actually all I have about repeated measures ANOVAs. Anybody have any additional points of clarification on these that you would like to discuss?